Welcome to the second part of the lab. We're again going to test the same three metals. So in the last experiment, we used magnesium, calcium, and aluminum. Notice how all of them are just shiny metallic gray substances. So we're using these same three metals as we did last time, except instead of using water, we're going to use hydrochloric acid to get a reaction out of it. Now, the thing about using hydrochloric acid is we can no longer use red litmus paper to test whether or not a reaction occurred, because red litmus paper just stays red in an acid. So if I'm trying to compare what's going on with red litmus paper while using acid, the paper is just going to stay red the entire time. We're not going to see a result. So we won't be using red litmus paper. Instead, we'll be using a thermometer. So this is a thermometer that we use in labs. And if you look at it, it's basically just a digital thermometer. It's got a probe, which we can stick into whatever reaction we're trying to study. And then you get the result over here. So if I turn that on, you can see we're noting our temperatures in degrees Celsius. So we're using degrees Celsius instead of Fahrenheit because degrees Celsius is the standard unit for measuring temperature. We don't use Fahrenheit when we're doing lab work. All right. Before we can start doing any of the reactions, we should first know what the normal temperature of the acid is. So what I'm going to do is I'm just going to put a few drops of acid in here. Don't need a lot. And what I'm going to do is I'm going to stick the thermometer in there and see what the temperature reads. Unfortunately, you can't see the digital scale on the camera right now. So when I get a final temperature reading, what I'm going to do is I'm just going to write it down over here so that you have the data available to you. So once the temperature has leveled off, which for me it has leveled off at 22 degrees Celsius. So I'm going to go ahead and write 22.0 degrees Celsius. That's our baseline. All right, now we're going to try seeing what happens to the temperature when we start to add acid to different metals here. So we already know what happens when magnesium reacts with water and when calcium reacts with water, and you were able to use that to tell which one was more reactive. Was magnesium more reactive or calcium more reactive? So let's test magnesium and calcium again and see if this experiment gives us the same results, or are we getting something different here? And we're also going to try and test magnesium and aluminum to see, can we tease out a difference between the two in this case? So I'm going to go ahead and start with aluminum since we need this result. We don't have a result for this. We don't know if magnesium reacts more or aluminum reacts more. So let me go ahead and add some drops of acid to aluminum. I've added lots of it to try to get it to react. And what I'm going to do is I'm going to set the temperature probe in it. And I'm going to wait and see if the temperature changes. So the idea here is if a chemical reaction occurs, even if it's a very small chemical reaction, and even if we can't see it with our eyes, some amount of heat is either going to be produced or consumed. So if we see temperatures that are different from our baseline temperature, it means something happened. If we see temperatures that are either the exact same as our baseline temperature or very, very close to it, then almost nothing happened here. So after waiting with the thermometer for a little while, I'm noticing that my temperature is not really changing from 22.0. So let me go ahead and write that data. With aluminum, after the reaction, the temperature is still 22.0. All right, let's try for magnesium and see what happens. So for magnesium, I'm going to go ahead and add plenty of acid. Note that we're already getting a reaction and some kind of smoke seems to be coming out of this. So I went ahead and stuck in the thermometer as quickly as I could. And what I'm going to do is I'm going to keep watching the thermometer for as high of a temperature as I can get. And I'm going to record the highest possible temperature. So you already saw it bubbled and foamed. You may have heard the sizzling in the background. And the highest temperature that I got out of this before the temperature started to go down again was 40.3 40.4. So I'm going to go ahead and write that it was 40.4 degrees Celsius. It's definitely different from our baseline. So you can see what's the temperature you get with aluminum. You can see what the temperature is you get with magnesium and it reacts. But you could also see magnesium reacting. Even now, you can see the bubbles being released slowly from the magnesium into its surroundings. So that magnesium is definitely reacting because we can see it bubbling up. Let's see if we can. And if I add a little more acid, you can see I started up the bubbles again. So the magnesium is definitely reacting with the acid. Now, if you think about our previous experiment where we compared magnesium and calcium, it looked like calcium reacted more than magnesium. So go ahead and see if you can make a prediction of, do you think, based off of what you observed for water, do you think calcium is going to have a higher or lower temperature than magnesium? Let's go ahead and check out and see what actually happens. So I'm going to go ahead and add plenty of acid in there. I'm going to go ahead and dip the thermometer in as quickly as I can. The temperature has already gone up to 64. It's still climbing, so I'm going to let it go to the highest temperature that it can go to. It just crossed 70, and we can see calcium is still reacting like crazy. It's overflowing out of the well. So the temperature went all the way up to 73.4 before it started to go down again. So let's go ahead and write that data in. It went up to 73.4 degrees Celsius. So this was our baseline. And by baseline, we mean that's the temperature of the acid when nothing was reacting with it, just when it's sitting in the well over here. With aluminum, we saw that it was the same temperature as the baseline. With magnesium, we saw it was a little higher, and it was highest with calcium. And even visually, you can still see magnesium is still releasing tiny bubbles. With aluminum, that might be a bubble over there, but I'm not entirely sure it's from having reacted. But over here with calcium, you can see that very obviously something happened. There was definitely a reaction.